All right. I think we have 4 of our presenters. Let's just wait a minute and see if we get the last one. All right. That's good. So, welcome to Tools and Environments 2. So we're going to have this session now, which will go up to an hour, and then we have an hour's break, and then we do Tools and Environments 3. So we'll hope for the best here. Zane, do you have any? Zane is our student volunteer assistant, and do you have any advice for our participants and speakers?
Yeah, I think maybe we'll try to aim for 5 minutes per presentation, and then we can do Q&A and everything at the end. So just so that gives everyone their 5 minutes. So in case someone goes overtime or something like that. Yeah.
Absolutely. Are you going to play timekeeper?
Sure. Yeah, I can play timekeeper.
So why don't we do this? Let's agree that it's 5 minutes, but we won't cut people's microphones off until 6.
Yeah.
Okay, because we have at least a little bit of spare time in this session. All right. So with no further ado, let us just jump in. The first paper is, are you still working on this? An empirical study of pull request abandonment. And the speaker is Zhixing Li, who's an assistant professor in the College of Computer at National University of Defense Technology in China. So over to you.
Hey. Hello, everyone. Nice to meet you online. It's my great honor to present our empirical study on pull request abandonment. Nowadays, pull request has been the main primary method for open source developers to collaborate online. However, pull requests are never perfect and ready to be merged at the very beginning. Pull request submitters are expected to follow project integrators' review comments to revise their code until integrators are happy to merge their pull requests. Unfortunately, some contributors may give up revising their code, leaving their pull request abandonment. Should be here with the effort of not only contributors but also the integrators. Therefore, we are interested to figure out the reason about why contributors abandon their pull requests, what impacts pull request abandonment to the result in practice, and how integrators cope with the abandoned pull requests. To answer our research questions, we performed a mixed methods empirical study. First, we manually examined the set of abandoned pull requests collected from 5 GitHub projects. Basis, we built this taxonomy of the recent impacts and the coping strategies of pull request abandonment. Then we performed surveys with GitHub developers to validate and quantify our manual findings. For the first research question, we identified 12 main reasons for pull request abandonment, which can be grouped from 3 aspects. First, we found some pull requests were abandoned due to process issues like lack of answers from integrators and disagree with integrators' opinions. Personal issues can also lead to pull request abandonment, like lack of time, lack of interest to make more contributions. Some pull requests are abandoned because they are not required or compatible. For the second article, we observed 7 impacts of pull request abandonment. Among them, the commonly mentioned ones include clustering pull request list and wasting integrators review effort. Regarding the third RQ, we found 6 strategies. Assigning success is the most popular one. Additionally, if the abandoned pull request is not that important, integrators may advertise it in the community and expected some volunteers to pick it up. Based on our findings, we propose the suggestions to better deal with pull request abandonment. On the one hand, pull request abandonment should be avoided, for example, by maximizing automation to reduce human effort. On the other hand, once a pull request is abandoned, the platform should automatically recommend the proper successor to pick them up. That's all for my presentation. Thanks for listening.
Okay, well, thank you very much. That was a good, quick overview, and I'm sure we'll have some questions at the end, so don't go away. Thank you. All right, so let us, if you'll stop sharing your screen, we'll go ahead. And the second speaker for our session is Colin Gordon, and the title of his talk is Towards Property-Based Tests in Natural Language. Colin is on the faculty at Drexel University in Philadelphia. All yours.
Great. Thank you. So I guess let's talk about property-based testing. So I've been thinking about this problem for a while of natural language specifications, which is sort of this long-standing ideal in software engineering, because we'd really like to be able to just describe our software behavior, whether it's unit tests or up through the top level spec, in natural language and have that mechanically checked against the actual behavior of our code. And this is a really fundamentally hard problem for all kinds of reasons, among others, this open vocabulary problem where every new program domain or even just new code base in the same domain might introduce or redefine even terms. And you need to handle those new meanings very precisely in order for this natural language spec to actually be meaningful in comparison to your code. Of course, I'm not the first person to think about this problem. Lots of people have worked on this before. Most of that work has been based on templates, things like regular expressions, sometimes context-free grammars, which can work really well in some domains, but they do have limits. So they can make it hard to express certain kinds of things. They can be hard to extend. And so today, the modern answer to this, if we want to generalize past that, is we throw machine learning at it, right? Well, you can do that. And actually, there are a couple cool papers at ICSE this year that do that for similar problems. But I went a different direction. Because if you look at modern machine learning systems for NLP, large neural networks, it's really hard to fix an individual word or extend it with just one word on top of the need for huge amounts of training data. So I looked at a different direction towards some really classic work in linguistics, because linguists have spent decades building rich formalisms for modeling compositional semantics, right? This idea that the meaning of a sentence is built up from individual words and have their individual meanings. So categorical grammars is this family of approaches for doing this that's been extensively vetted for these kinds of purposes by actual linguists for all sorts of natural languages and sophisticated grammatical constructions from these languages from all kinds of different language families. So it's not limited to something like just English. And for our purposes, something that's really useful is the fact that their notion of what's the semantics of a word or a sentence, it's a lambda calculus with something that looks like a Boolean. So it's a small functional programming language. And any functional programming language with these properties will fit, including property-based tests, as they've traditionally been expressed using higher order functions. So property-based tests are this kind of parameterized unit tests that generally have this form at the bottom here. For all generated inputs, some property holds. Usually that property exercises the code you're trying to test. And if you look at this from a linguistic perspective, this actually doesn't look too different from the normal semantics you'd expect for a sentence involving a quantifier. So I took this and I ran with it. You can basically, the idea is you take, here are two of the inference rules for categorical grammar. There are a number of others, but they basically say that if you have a couple sentence fragments, say gamma and delta here, and they have different grammatical types, maybe one of them is looking to the left or to the right for a certain kind of grammatical clause. If you put them next to each other in the right order, they combine and you get something larger. And not only that, but you combine their semantics, in this case with function application, but other cases are composition or sometimes things a little more involved. So if you take these rules and you add a lexicon, basically a database of, for each word, what are its possible grammatical rules and semantics with overloading allowed, you end up building these logical derivations that witness that a certain natural language utterance parses to some meaning. So this derivation that I've shown just the bottom of shows that every even integer is odd is a grammatically valid English sentence whose semantics are given by this property-based test that actually would fail if you ran it, which is important because you only find bugs when the tests fail. So I took this and applied it to a small case study. So I built enough of a lexicon by hand to tackle the examples from the property-based testing chapter in a draft textbook. Made a couple very minor adjustments to get off the ground a little quicker. Used an off-the-shelf categorical grammar toolset with my custom lexicon to parse English descriptions of these tests into basically the AST for a property-based test, which then you can sort of naively transliterate into whatever language you want. I happen to pick JavaScript. So what happened? Well, out of the 7 examples from this textbook chapter, they all got correct translations, but 3 of them failed because they were underspecified. In this case, probably intentionally. It's a textbook. You like to keep things simple when students are learning things, keep them focused. But this is very similar to the cases where we unintentionally underspecify things as well. So I think this is promising early results. To poke at the question of, are we going to hit grammar limitations?
We're going to hit time limitations, Colin.
Okay. Are we approaching 6?
We are over 6.
Oh dear. Okay. Then I'll skip to the end.
All right.
All right. That's it. Thank you.
Okay. So we can handle some of that in the Q&A later.
Sure.
Sorry about that.
All right.
Sometimes, the chair has to be the tough guy. What can I say? All right. So let us continue. The next paper is presented by Hyungjin Kim from Samson Electronics, Samson Research Software Engineering Team, where they develop software quality tools. And the title of his paper, their paper, it's a team, a unified code review automation for large-scale industry with diverse development environments. So all yours, Hyungjin.
Nice to meet you. This is a short paper talk titled Unified Code Review Automation for Large-Scale Industry with Diverse Development Environments. I'm Hyungjin Kim, a software engineer in Samsung Research. I'd like to share my experience on applying code review automation in Samsung Electronics. Code review automation is, as you know, a process of generating code reviews, which are from the result of predefined set of tools. It reduces human efforts in code quality assurance, and the automation may have rapid code review, so it takes an important role in modern code review activities. However, in fact, there are so many hurdles for adopting code review automation in a real-world industry area. Let me introduce examples in Samsung Electronics. Samsung Electronics manufactures many kinds of products. As you know, mobile phones named Galaxy series is the representative product. Also, these items are also the products of Samsung Electronics. Not only the various of products, but also the size of each product, each software are getting larger and larger. Naturally, review requests contain a large size of code changes. These environments make big hurdles to code review automations, as I said. to manage these huge size code, in Samsung Electronics, products adopt their own source code management systems and Git and Helix core, Purpose Helix core, and code review systems, GitHub Enterprise Edition, and Gerrit and Purpose Helix Swarm. In addition, there are a number of development teams in Samsung Electronics, so they have their own development processes and cultures, such as their own quality assurance policies and various analysis tools. Because of these huge size code changes and various cultures, a code review automation system requires several important quality attributes. First, extensibility. Second, scalability. And the last one is performance. We developed an automatic code review system called Code Review Bot for code review automation to take root. Code Review Bot can address various analysis tools and code review systems. As I said, developers in Samsung Electronics use these three code review systems, and Code Review Bot supports all of them. It is based on abstract module for a review system to consider extensibility attribute, as I mentioned before. We wanted to invoke the schedule analysis services, so we designed the task work module to consider the second attribute scalability. Also, we took parallel processing to run services to improve performance, the last attribute. Code Review support diverse analysis services. During as a simple services, a check spell, another name is typo, and commit size services. Also, a potential defect services which find various critical defects or cause mess in the code changes is one of the important services. Besides, Code Review Bot provides coding style services, test coverage service, ground rule service, and some more in-house services, and we develop new and advanced services continuously. The last page. Code Review Bot is successfully deployed to whole development teams. During the single month, August 2021, the huge size of review requests, heavy requests are requested to Code Review Bot, and more than 60% detected items from the potential defects and checklist services of Code Review Bot are really fixed and merged into real-world product code in Samsung Electronics. By developing and operating Code Review Bot in Samsung Electronics, we provide developers with lots of insights to improve their code quality. In the future, we will take more activities and applications to produce much more outcome. Thank you for listening.
Well, thank you. All right. We made that one on time. So, thank you. All right. So we are ready to go forward. Our next speaker is Melinda Dalhara, who's a PhD candidate in the Department of Computer Science at University of Colorado Boulder. He does research on software refactoring and static code analysis. The title of the paper is Discovering Repetitive Code Changes in Python ML Systems. So all yours, Melinda.
Hello, everyone. So I'm waiting to share my screen.
Yeah, I think Hyungjin has to unshare. There we go.
Thank you. Okay, I hope everyone can see my screen. Okay, let me start.
Yes, good.
Cool. So I'm Malinda. I'm a PhD candidate from University of Colorado Boulder. So this is my talk, Discovering Repetitive Code Changes in Python Machine Learning Systems. researchers capitalized many applications of the repetitiveness of the software. For example, automatic program repair, which mine previous fixes and develop systems to automatically fix the similar bugs. Likewise, we can consider API recommendations and library migrations as two other examples of repetitiveness of the softwares. So even though these applications conceptually language agnostic, their implementations are limited to only for few programming languages such as Java, C#, C++. So thanks for the rich ecosystem of machine learning frameworks written in Python, such as TensorFlow, PyTorch, there is a rapid growth of machine learning systems written in Python. Since the implementation of the applications that exploit the repetitiveness is limited to the languages such as Java, the Python systems do not benefit from these applications. Therefore, machine learning developers' toolset is far behind the toolset of other developers. So there is a vast ecosystem of repetitive code analysis tools developed for Java. For example, TypeFactMiner. It mines the repeated type changes in Java systems. Likewise, we can consider Migration Miner, CPAD Miner, and Refactoring Miner. So these are just 4 examples of such Java code analysis tools. We have a vast ecosystem of such repetitive code analysis tools. These tools take source code as input and pass the code to AST and infer results based on the ASTs. So none of these tools have been developed for Python, which posed a significant hurdle to conduct mining research in Python systems. So it is not feasible to re-implement the tools from scratch to Python either, because it requires a significant amount of development effort. To overcome this challenge, we propose Java 5.5, a technique to adapt existing Java code analysis tools to Python. It leverages the similarity of Python and Java at the AST level. While statements, for statements, method invocations, all of these AST nodes exist in both Java and Python. We found that there's a 90% overlap in both the languages at the AST level. So Java 5.5 leverages this similarity. Using Java 5.5, we adapted state-of-the-art Java code change pattern mining tool, CPAD Miner, to Python. To improve the CPAD Miner and make it refactoring aware, we adapted Java refactoring miner to Python. And then we integrate both the tools to improve the CPAD Miner. And we call the final tool as RCPAD Miner. So RCPAD Miner mines the version history of Python systems in refactoring aware manner. To analyze the repetitive code changes in machine learning systems, we first collected highly rated 1,000 machine learning systems. Then we executed RCPAD Miner on the commit history of all the machine learning systems. Running RCPAD Miner on 1,000 systems produced 28,000 fine-grained code change patterns. So as the next step, we performed thematic analysis on the top 20,500 patterns, and then we surveyed 97 developers who performed these changes. So this slide briefly summarized the results. So this actually, I picked a couple of important results only to present you today. We validated 20,062 refactorings reported by Python version of refactoring miner, and it reported 95% precision. Our improved CPAD Miner reported 15% more code change patterns, and then it also reported statistically significant more code change instances per pattern. Then we analyzed top 20,500 code change patterns, and we thematically analyzed them. And we report 22 code change themes in Python machine learning systems. So the code change shown in this slide is one such example where the developer transformed the for loop based computations to numpy.sum, which is a highly optimized API to compute sum of elements in a list. So you can find 22 such code patterns in our paper and in our companion website. So yeah, feel free to check our paper. So as a contribution of this work, we provide many ideas for code automations for the tool builders. We also release best practices for evolving and maintaining machine learning systems for developers. developers can adapt them and enhance their code bases. We also provide code examples. Educators can use them to teach machine learning developers. Most importantly, we provide tools for researchers to statically analyze Python and then machine learning systems. Our framework can mine repetitive changes in any application domain in Python systems, and it is not limited to machine learning systems. In this research, we instantiated our framework on machine learning systems. So we would like to invite researchers, colleagues to build upon our results. We are looking forward to interacting with you. So this concludes my presentation. So finally, we graciously acknowledge the funding support from NSF and PPI Center. Thank you.
Thank you. 5 minutes and 58 seconds. So worked out just great. All right. So we have the final paper in our session, and looks like it's already up on the screen. So you can see the title is OJX-Perf, Featherlight Object Replica Detection for Java Programs. The speaker is Bolin Lee, who is a fifth-year PhD student at North Carolina State University, who's working on parallel computing and compiler techniques and systems. So over to you, Bolin.
Okay, sure, thanks. Hi, everyone, I'm Bolin Lee. It's an honor to have an opportunity here to give a presentation today. So you can see my paper developed a tool named OJX-Perf, which provides a Featherlight object replica detection for Java programs. So nowadays, Java is one of the most widely used languages in production. And Java can be used to build applications for a wide range of platforms. So developers want their Java-based applications to run faster and consume less energy. So I would like to say the Java performance everywhere. So the performance issues detected by our tool OJX-Perf is object replica. So here I give the definition of the object replica. We have two objects, O1 and O2, and they have the same allocation context, which means they are allocated in the same place of the source code. If every field of two objects are identical, then O1 is a replica of O2. So why the object replica appears? Here I give an example of image processing. We investigated a Java application that divides a graph into small size blocks, like this fish picture. To process the image, the Java application creates an object for each block instead of creating a single object for the whole graph. Consequently, some of the created objects have the same content due to the good value locality among the adjacent blocks, like this picture. So you can see some adjacent blocks have the same color. So in our paper, we proposed OJX-Perf, which is an efficient object replica detection for Java. To monitor object replica, what OJX-Perf needs in Java. Here are at least the three abilities, and I'm going to talk about each of them briefly. So first, how to enable OJX-Perf to instrument object allocation. In fact, we use ASM framework to do it. So ASM provides APIs to traverse Java classes, so we can hook, so we can instrument object allocation by hooking the object allocation keywords. Then OJX-Perf can capture the object information such as the allocation size. So next is about how to monitor various hardware events and the CPU execution. To monitor hardware events, we use hardware performance sampling unit, the PMU. So PMU can be used to count various hardware events such as memory loads, stores, CPU cycles, cache miss, or heat. Intel offers a precise event-based sampling, the PEBS, which provides the effective address at the time of sample. To monitor the CPU execution, OJX-Perf uses hardware debug registers to track the CPU execution for debugging when the program counter reaches an address or an instruction access a designated address. So finally, how to enable OJX-Perf to break JVM abstraction? We take advantage of the Java Virtual Machine Tool interface, the JMTI. So JMTI is a native program interface of JVM, and JMTI provides a number of event callbacks. For example, capture JVM start and end, thread creation and destruction, method loading and unloading. here is an overview of the OJX-Perf's profiling. So OJX-Perf consists of two components, object-centric analysis and duplication detection. So this is two components are implemented in two agents, a Java agent and a GMTI agent. The Java agent adds the lightweight bytecode instrumentation to capture object allocation information, and the GMTI agent enables PMU to simple memory access. So when the PMU interrupts a thread with a simple address, OJX-Perf associates the address seen in the simple with the Java object, enclosing that address. So this process is called object attribution. Moreover, to identify the object replicas, GMTI agent programs the debug registers to subscribe to watch point. Lastly, I'd like to give the conclusions of our work. First, we developed a novel object-centric, value-aware profiling technique in OJX-Perf. And to reduce the measurement overhead, OJX-Perf employs the PMU in conjunction with hardware debug registers and the minimal bytecode instrumentation. Also, we quantify the theoretical lower and upper bounds of duplication analysis. OJX-Perf is applied to unmodified applications, JVM, and the operating system. And lastly, guided by OJX-Perf, we are able to obtain non-trivial speed ups by removing object replicas in many Java programs. All right, that's all my presentation. Thank you.
Okay, well, thank you very much. Wow, well, we got through that very efficiently. That gives us plenty of time for questions. So what I thought we could do, well, the applause is still coming. Thank all of the authors for their presentation work. So why don't we start with the two questions that are in the chat? There's a question from Mathieu to Colin, which said, I really like the idea. I was curious about how code terms that appear in NL fragments were handled by the grammar. Do they need to be included in the lexicon? So over to you, Colin.
Thanks. Yeah, so they would need to be handled in the lexicon. So for the couple small programs that were in the this exploratory study, yes, there had to be individual lexicon entries for, say, the functions that were being tested.
Okay, good. And Colin, you have a question for Melinda.
Actually, I thought it was very cool, but I was also wondering, like, so at least the way you set it up, it sounded like this very strong similarity between Java and Python ASTs was important to this approach working. And I was wondering, how much similarity do you need for this technique to be profitable? Like, could you push it to something like a functional language translated into Java, or are there really weird features you can think of that would just, regardless of overlap, would really cause problems?
Thanks for the question. It's a really good question. Again, like thanks asking that question a little bit early, because it gave me some time to think about it. I cannot give you a definitive answer, like it is 80%, 90%, but if it is large, so larger the better. Like if it is 95%, if there is a 95% similarity, so it is better than the 90% similarity. For example, if we think about like C++, so it is like, I think there's more than 90% overlap between C++ and Java. So we should be able to adapt all the existing Java static analysis tools to C++, and it should be easier than Python, because one of the challenge that we had when we adapting Java to Python is, like, if we compare the two ASTs, in Python we don't have type information. If you think about the AST, so for the static analysis tools, some tools needs this information type information to produce accurate results. to overcome this challenge, what we did was like we used type inference. We used a third-party tool from Google. It's called PyType, and it does a good job when inferring type information. So what we did was we get the type information for all the program elements from PyType, and then we augment the Python AST with type information before feeding it to the static analysis tool. So it's a one challenge. Likewise, there are I cannot think about any other challenges because all of these tools use AST as its input. But if there's a tool that require any other information from compiler, so we might not be able to adapt those tools to Python because Python is an interpreting language and there's no compiler there. So
Okay, thank you.
so the answer to that question depends on the tool and also the language. Thank you for the question.
Thank you. So one more question in the chat, or actually it's three questions. Lim, you have questions on the OJX perf talk. So why don't you go ahead with those?
Yes, thank you for the question. For the first question, I would say OJX perf supports JDK 1.8 and the following newer versions of JDK. For the PMU, I would say using PMU is one of our features in our tool. And the reason we use the PMU for profiling because the statistical strategy can reduce the profiling overhead greatly. And at the same time, we in our paper, we develop a way that doesn't sacrifice the analysis accuracy when using the statistical strategy. So I would say it's not required to use PMU for profiling. We use PMU just for reduce the overhead, profiling overhead, because all the existing tools have huge overhead to detect the object level information. So lastly, no, our work is not related to NUMA, so it's not required to use a NUMA machine to use our tool. Thank you.
Okay, well, thank you. So are there other questions either from the panelists, speakers, or anyone in the audience that you can?
There are a couple earlier in the chat.
Yeah, let me see. Yes. So there was a question on unified code review automation, right? And let's go all the way back to the first one. Thank you, Colin. Syed Hassan had this question for Xixing on the abandonment paper. How do you think we can better understand or tackle the abandonment phenomenon? What are some future works that you recommend the research community to investigate?
Sorry, I didn't catch over that. Can you repeat your question? And
if you open up the chat window, you can see it.
Sorry, I cannot see the chat.
Okay, so the question is, first, great work. Thanks for your presentation. How do you think we can better understand or tackle the abandonment phenomenon? What's some future work that you recommend for further research investigation?
Okay, we propose the suggestion to develop a tool to automatically recommend the successful abandoned pull requests. On the other hand, we also suggest a platform to avoid pull request abandonment. For example, by maximizing this automation to reduce manual effort and to support online update of pull requests. So if the contributors abandon the pull request, integrator can directly update the pull request and merge it. Thank you.
Oh, good. Thank you. So now there's another question from Mr. Lim, and this is on the unified code review automation, the Samsung paper. and the question is points out that there are a lot of open source based code review bots, and the question is whether Samsung's code review, whether there's any plan to open source the Samsung code review bot. Also, when automating code review tasks in the field, what is the most repeated code review? What are the biggest obstacles to automating code review tasks? So that's, I think, really 3 questions. Mr. Kim.
Yeah. Thank you for question. That came from me. Now, there are not a plan to spread out of Samsung Electronics by making open source project, since some in-house services and logics are confidential. However, we want to do so later when we get an opportunity to spread it. We'll use that time. Also, I think the biggest challenge is the scale. When a specific division, I cannot say what it is, request to apply our code report to their DB systems. At that time, they said that the system contains hundreds of projects and their code lines are about 1 million lines per day. So the scalability is the difficult hurdle to make our system. I think extensibility is the best important, but scalability is the biggest hurdle. And thank you.
All right. There's a follow-up question, I think, also on this unified code review, which says Android and Tizen platforms use Git. Samsung mentioned that they utilize both Perforce and Git. And the question is whether popular Git alone is sufficient for software development.
Thank you for another question. But excuse me. I can understand in detail. Sorry.
I think the question really boils down to whether Git alone is sufficient for software development, or whether you have a particular need for Perforce or some other tools.
Maybe I think the review system for GitHub and Git is popular, and the enterprise edition is to use in-house tools to code review and purpose is to specialize to very big and huge product. On the other hand, Git is specialized to make some private repositories and some products. So both Git and Purpose are always used to make some products.
Good, thank you. So Boland Lee has a question for our last speaker about OJX Perf, and the question is, since your work targets on fine-grained code change patterns, what's the runtime overhead of your tool? That question is for...
I think this question
That's
is
for Melinda.
Yeah.
Yeah.
Runtime overhead. I think he is asking question about runtime overhead compared to its Java version. I believe please correct me if I'm wrong. So compared to the Java version, we did the performance analysis. So I don't remember the exact number. So if you're interested, you can go through the paper. So we didn't notice any significant runtime overhead compared to the its Java version. Um, um, for example, as I remember, for the Java to refactoring Java version, the median time of Java version is around 80 milliseconds. Then our tool required around like 100 milliseconds. It's like there were like always 20 milliseconds overhead for the Java refactoring for the Python refactoring inference tool compared to the Java version. So it obviously had some overhead because it does some transformations and also for the type information. So so there is overhead, but it's not a significant amount. I
Thank
hope
you.
I answered the question.
Okay, good. So I have a question for Colin. And so once upon a time, I was, I don't know, head of product development for a startup, which I knew was going to fail. But what they were trying to do was to automate this whole natural language to code. But they used an intermediate step. They were really trying to produce use case diagrams and scenario diagrams, which then they could hand over to other people to implement. And one of the things that seemed to be the case was that certain sentence structures just were bad, particularly passive voice. And so one of the things that I was wondering is whether you do some upfront or could do some upfront language transformation before you throw it into your analysis tool.
Sure. I mean, that would definitely make sense. I mean, like you said, and passive voice is not the only thing where the grammar gets a little bit weird or a little bit more complex. And so, I mean, any kind of transformation to normalize would make this easier for either my approach or, even other approaches in the literature. Certainly shrinking the space of expected inputs.
Yeah, and I think a lot of natural language analysis does that one way or another. They either limit the vocabulary or they limit the number of sentence types in the same way that if you're traveling and you have, just spent a few weeks trying to learn some language, you probably use a vocabulary of 1,000 to 1,500 words at most, and you use certain sentence structures that are pretty standard, rather than giving people the entire richness of whatever language it is. And it's a trade-off, obviously, that people either have to write something that is easier to comprehend, or you have a harder analysis problem at your end. Has that situation changed in the,
No, I mean, it's certainly, of course, the more complex sentence structure is going to lead to more complex treatments. One of the nice things that I like about the categorical grammar techniques that I've been working with is that most of that complexity tends to be pretty well isolated. So, like, I don't need to sit down and write special rules for long distance dependencies. There's, between 6 and 12 rules in different flavors of categorical grammar, and they resolve those long distance dependencies on their own. You just have to mark individual words with essentially whether they take long distance dependencies or local dependencies and which direction they look for them in.
Right. So, I mean, this is also somehow related to the notion of readability scores.
Okay.
That you could, when you look at a book that's written for young adults, or you look at a book that's written for beginning readers, all of these structures are obviously much easier than they are if you're trying to read James Joyce. So I think that that's all I had on that. So are there some other questions for anyone? All right. So we're just about done. If you will allow me, I have a lot of experience at listening to people give 5-minute presentations, both from the classes that I teach and from listening to people make presentations to investors. And doing it over video is harder because obviously you don't have the body language available to you, and so it's limited. So let me make a few suggestions for you for your future efforts. Number one, make sure that you're looking at the camera, not off to the side. Don't read your presentation. Make sure that you've tried it out. Rehearse, right? I mean, get up there and do your 5 minutes, record it a couple of times, look at yourself, see where you're stopping in the middle, seeing where you say, yup, like, because all those filler words make it hard to get your complete thought. The second is to make sure that the camera is at the right height. You'll notice that if you look at me, my camera, my face, my head is right in the middle. And so you may have to put your camera higher or lower, depending. One more thing is that the light behind you makes your face show up in the shadows. So as you work at that, try to either use something like a Lume Cube or something that sits on top of your laptop to put some light on your face, or something else, because these just make you look more effective. So those are my 5-minute pitch presentations ideas. And in your lives, you're going to be doing lots and lots of presentations. You have to remember that you're always out there trying to sell your idea. And if people are spending their time trying to understand you or trying to see you, it just makes it that much harder for you to be a convincing speaker. So I wish you all the best of luck. I think we're done with our session for this time, but if you take an hour and 10 minutes and come back, we'll have the Tools and Environment 3 sessions. All right, thank you all very much.
Thank you so much.
Okay, bye now.
Bye.
Thank you very much. Bye.
Uh-huh.